holding back insecurity, taking me 2 steps forward, 1 step back from you. I'm afraid if I try to reach too soon that you might back away. How can I try to hide a feeling that's so wonderful? How do I tell you that you're the fire burning in my soul? 'Cause when you look in my eyes, I'm a rabbit in the headlights. And when you're touching my skin, I'm a river in the moonlight. It's got to be the right time, the right place, the right kind of moment. It's got to be the right kind of feeling and deeper emotions. Cause when you look in my eyes, I'm a rabbit in the headlights. And baby, when you're touching my skin, I'm a river in the moonlight. It's got to be.
Take it, I surrender the attack. Never mind the killing, taste enough. Stripped to the core, a moment was stolen. Time has won, wound was sore. A moment was stolen. Time has won. Beyond memory, faces I see mean nothing to me. Only shadows in my dreams. Beyond memory, why is it me? And no one can see. Only shadows in my dreams. Fake it, I surrender to the fight. I can see the darkness in your eyes, down to the bone. Your victim was chosen. Time has won all alone. Your victim was chosen. Time has won. Beyond memory, faces I see mean nothing to me. Only shadows in my dreams. Beyond memory.
Happy Wednesday, hackers. Welcome back to another stream. Tonight we're going to be doing some programming practice on a platform that I haven't used in a while, but I have always loved, which is Exercism. Let's just check on the poll here, just to see. I did a poll on Twitter asking what languages we were interested in tonight, and it's a tie between Python and Rust. So tie goes to the language that I, like more, which is Python. So we're going to do Python, also a little bit more accessible for new coders. So let's check out Exercism. Exorcism, like exercise, not, like you need to call a priest because somebody's head is backwards. So Exercism.io is a platform that it's really evolved in the last few years. But the basic concept with Exercism is you sign up. There are a bunch of different language tracks. I mean, look at how many languages that they have support for, right? Um, Vim, I guess, it's Turing complete. Um, but Hadoop, there's Rust, C++, straight up C, Racket, which is a great Lisp. Um, there's our Python, our friendly noodles, Clojure, all sorts of cool stuff. If you want to learn a language and learn it well, I think that Exercism is one of the first places you want to go once you have a handle on the syntax. And here's why. They are going to walk you through a series of programming challenges, and the way that you're going to do it is via test-driven development. So basically, you download the challenge, and we're going to do this today. You download the challenge, and each one of them has tests. And so you run the tests, they start failing. They start in a failing state, and you have to write the implementations such that they pass, and then you submit. That is when the cool parts of Exercism really kick in. So Exercism is a community, and what there are mentors in the community. So you submit your code examples, and then mentors actually, if you sign up to do mentoring mode, mentors are going to review your solutions and suggest how you might have been able to do it more efficiently, or a little bit cleaner. And you can take that and then you can resubmit your solution, or you can use it in the next challenge. So it really is a community of people who are passionate about teaching people how to program. So let's go through it. Let's go through how you get going in Exercism, and let's get some tunes going at the same time. Let's see. I think a little lo-fi is appropriate for this. Yeah. Nice and chill. All right, let me close out of the incognito window because I was in incognito mode to show you the front page. But I don't need incognito for what we're actually doing. So, when you log in, and you can log in with GitHub or set up a separate account. I pretty much always log in with GitHub. You'll be asked to set up a language track. But before we even touch the language tracks, we need to set up the command line interface. That's the first thing. So this will be a command line interface situation. And if you're not comfortable with that, I understand, but it's a good thing to get comfortable with, especially if you're going to be doing programming. So they kind of hide it once you're signed up. So let me get here where it says installing the CLI. And they also have the interactive CLI walkthrough. And it'll take just a minute, so let's go through it. Let me zoom that in so it's just a little bit bigger. So which OS do you use? Now, as you can see, I'm on a Windows machine, but I'm going to be programming inside of WSL, Windows Subsystem for Linux. So my operating system is Linux. It says you can use the snap package to install the command line client or install it manually. Now, snap is mainly Ubuntu focused, which I am running, but because I'm in WSL, snap doesn't run the way that you would expect, so I'm not going to use the snap package. I would use the source code, which is probably the more accessible way anyway. So, how do we do it? We click on use the source code. It's available from GitHub, and so I'm going to go grab that. Let's open up the releases page here. I'm on Linux 64-bit. So I'm gonna just copy that link address rather than like download it and move it around. Like I can do that. But let's get command liney. So here I am in my command line. I'm in the Exercism folder that I've set up that I want. I'm going to use wget and download this thing. Okay. If I do an ls, there it is. Cool. And then what's the next step that it tells me? It tells me I'm going to tar xf for extract the folder or extract the file, that thing. So let's do that. Tar xf. Okay, you can kind of see that all this stuff came in. And there's the license, there's the README, there's the exercism.fish. Okay, we don't need most of this stuff. Like if I cut out the exercism.fish, it's a whole bunch of stuff where it's like auto completes for the binary. What I really need to do is move this binary into my path. And so to do that, I'm gonna actually I'm gonna sudo make dir opt exercism, and then I'm gonna sudo mv exercism and to opt exercism, and I'm gonna move the shell folder to opt exercism. Okay, so you'll see there's less stuff here, right? And I don't need the license right now, and I don't need the README. So now, I can't access that command right now, right? So I can manually say opt exercism, but I can't just quickly type exercism because it's not part of my path. So I have a couple of ways to fix that, but I'm using fish, so your mileage may vary. But what I'm going to do is I'm going to set up my fish shell to work correctly by doing this. So you can see that I've actually modified the path already to add cargo stuff for Rust. So I'm just going to do that a little bit more and add opt exercism as well. And it still won't be there because I have to reload my shell, so I'm just going to do exec fish. And then now I have it. So if you're not used to working with the fish shell, or you don't use the fish shell, that part would be meaningless to you. But the big thing to understand is we have to get this thing working with our path. And in fact, the walkthrough will walk you through how to do these things. Like it'll have you set up all of these. Okay. And now let's look at what the exercism command gives us. So the first thing we're going to want to do is configure it. And what you'll see is exercism configure. We need to give it a token. Now, where's the token coming from? It's actually it should be in the walkthrough. Let's keep going. Yeah, so this is my token, don't use it. But you can find your token on the settings page once you're signed up, so no problem there. And so I'm gonna just copy that token and boom. Now I have to fix the workspace because the workspace isn't right. I'm in the workspace that I want, so I'm just going to set it up here to PWD. And you see that my workspace has changed. So now we're ready to do some programming. Kinda. Let's start the Python track and see what that looks like. Unbelievably, I haven't done the Python track on this, so this will be cool. Now, other tools that you're going to want if you're going to get started programming here. You're going to want a text editor of some flavor. I'm going to use Vim, of course, but the second best option would be Visual Studio Code. And VS Code is cool because even if you install it on Windows, it has... What do I even have open here? Oh, cool, this is my website. Great. But it has a WSL component, so you can see, like, I can actually open stuff in WSL. If I wanted to, oops. Yeah, so I could go find other folders in WSL and use that as well. I really like Vim for this, for reasons which will become clear, but you do you. Let's do some Python. So like I said, Python, I'm in practice mode, by the way, but when you select a track, like let's select, what's something I'm not gonna do? PHP. I've had my fill of PHP, thank you. But if I click join the PHP track, it'll ask me, right, if I want to do mentored mode or practice mode. And mentored mode is the one we were talking about before, where somebody's actually going to comment on your work. Okay, but Python it is. So here we are. I'm going to do hello world, right? Real simple. But here it gives you the instructions for how to get this going, right? Exercism download -- exercise equals hello world, and then track equals Python. And then you submit and you send the submission file. It's pretty helpful. Now, as I said, Exercism is test-driven development, which means that we're going to have a testing framework. And for Python, that's going to be PyTest. Okay. Now we won't have to write tests so much with this, but we will have to run them. So let's get this thing installed, and we're going to use pip to install it. PyTest. Cool. And I should have a PyTest executable. Sure do. All right, we are finally ready to start our first exercism exercise. So I'm going to copy the download command for this hello world. You see now I have a Python folder in there. So I'll cd into that and into hello world. And I've got a readme and a hello world and a hello world test. Yeah. And in this one, just say hello world. Write a function. So here are the objectives. Gotta read the instructions. Write a function that returns the string hello world. Run the test suite and make sure that it succeeds. Submit your solution and check it. So the first thing is, we can just do pytest hello world test.py, and it'll run and it'll fail. If you want to see the tests, you can do that. In fact, I'll run the tests over in the right-hand side, and because I learned my lesson, let me split the window in such a way that the output doesn't go below my head. Now, yeah, so if I do pytest hello world test, right? So the test data will come over there, and then I'll fire up Vim in here. And let's open up the test file. Right, so not that tricky, right? From hello world, import hello. So what it's doing is that it's importing the hello world file where we're going to write our code. And then test say hi, assert equal. What are we saying is equal? The result of the hello function and the string hello world. So real simple. And then it just runs itself. That's what this is about. So let's open hello world.py. You see it's not implemented, right? There's nothing here. It just says pass. So to make it pass, remember, it's not a print statement. The instructions are very clear. And this is actually something I like about Exercism, is that it makes you think functionally, because test-driven development really works functionally. The function has to return, the function hello that we were looking at has to return the string hello. And what that means is that I have to write return hello world, like so. Now, if I've done that correctly, the test should pass. And it does. Okay, with that done, right, I can close out of this, and then I can run exercism submit hello world.py. And you see it's been submitted successfully. I can look at my solutions. And the secret sauce here is that Exercism is keeping track of kind of where you are. And so that's kind of how it knows what exercise to submit the solution to. And if I reload this page, it should show me that I've solved it. Yup. So over here, am I good with this one? I'm good with this one. I don't know about you, but I feel like this is an elegant solution to the hello world problem. So it says what's next, right? I can complete the solution. If I don't know if I feel good about it, I can request mentor feedback. I can see do this, right? For anything that you do successfully solve, but you want to see how it could be done better, definitely do this. View community solutions. It's as valuable, if not more so, than the ones on Code Wars. All right, we'll complete this, and you can publish your solution. You can allow others to comment. That's all fine. It's not like there's anything special here. And then let's just go on to the next exercise. So all of the ones that are unlocked are available to us, right? We can probably power through most of these. Hamming is a fun one. Twofer's less fun. Let's do hamming. All right, so we're gonna copy that download. All right, and if we need a reminder, actually, let me just fire up Vim. This is kind of neat. So I'll do Vim the right way. I'm going to use Nerd Tree to open up my little file browser, and you can see I've opened up hamming. This is the README. And I'll close the file browser. So here's my instructions, right? I don't have to go back over to the website if I don't want to. I'll open up a new tab, and I'll open up hamming test so I can see the tests. And then in a third tab, I'll open up hamming.py so I can actually see the function. So let's start in the README, right? Calculate the hamming distance between two DNA strands. So the idea is your body is made up of cells that contain DNA. Those cells regularly wear out and need replacing. That's neat to know. When cells divide, their DNA replicates. Sometimes during this process, mistakes happen and single pieces of DNA get encoded with the incorrect information. Okay, so if we compare two strands, there are 7 differences by position. Therefore, the hamming distance is 7. Right? Real handy concept here, and really handy to kind of work through solutions that require loops. Now, there are some kind of cool functional ways we could do this, but we'll start simply and then we'll work up from there. So we're going to be given, our function is going to be given 2 strings of DNA, 2 strands of DNA, and we have to calculate the hamming distance. So that's actually really handy to know what's coming into our function and what's going out of our function. Python is not a statically typed language. Nevertheless, it's really handy to always be thinking in terms of data types. That's kind of what you want to be doing when you're writing code. What data is coming into my function? What transformations am I doing on it? What data is coming out of my function? And you can, like if you wanted to, you could import the Python typing library and make it a typed language, but for now, we won't do that. So here are the tests, right? You can say that we have a function distance, and it is given 2 strings, right? And it should be 0. Which means that empty string should return 0, right? Not like an error or something. Now, it also says that there should be a value error that's raised when we're given 2 strands of different lengths. So that's going to be something that we have to write in our code as a safety. Okay, but other than that, it's going to be pretty simple. All right, so the first things we're going to do, right, is we're going to just return 0. Because that's the data type that we know we're going to be giving back as an integer. So let's write that here. And then over in our other window, I'm going to come back to the Hamming. By the way, you're seeing that kind of autocomplete over here. That's one of the reasons, or the hint information, that's one of the reasons I like using Vim for Python, is that its autocomplete is actually great. As is the you complete me buzzer. All right, so let's run pytest hamming test.py. It should fail a bunch of different ways, and it tells me at the end that 6 of my tests failed, 3 passed, and the reason that 3 passed is because the ones that expected 0 should have passed. Yeah. So let's start with turning this into a variable. Let's say count equals 0, right? And then we'll say for I in range. We're making some assumptions at the moment, and we'll fix that later, but the basic idea is that we're making the assumption that strand A and strand B are the same length. We'll handle if they're not once we get to that part of the code, but let's do the basic implementation here. So we're going to do the range len of strand A. The reason I'm doing it this way is because I don't want the individual characters. I mean, I do, but I actually want to get the index of the string, right? Just as a reminder, in Python, yeah. Just as a reminder, in Python, right, strings are indexed. So if I say taggart, right, and then I use the 0th index, it gives me the capital T. If I do like 3, it'll give me a G. And by the way, if I give it -1, that'll be the end of the string. So I want the index number. I don't want the character itself at that index for I. I will want it for the comparison, but I'm not there yet. Now and then. I will say if strand A at index I is not equal to strand B at index I, we're going to increment the count. Okay? That's it. If they don't match, then we increment the count, and then we'll return the count. Let's see how that does. Okay, 5 passed and 4 failed. Now let's see which ones failed. So we know that the ones that have value errors are not failing because we're not raising the value. And it says string index out of range. Disallow second strand longer. Same problem, really. So I think most of these are about... Yeah, all of these are the value error ones. So let's fix that. And we'll do that right up at the top, right? Before we even initialize count, because we won't need it if we're not running the computation. So we'll say if len strand... Wow, cannot type tonight. Is not equal to the len of strand B, raise the value error. And that's a panic, right? That's a showstopper. So that's as good as a return for our function's sake, which means that we won't even need an early return here. That should stop the show. Let's try that test again. What? Let's take a look at those tests again. Raises with message value error. Let's check the Python docs to make sure we're using value error correctly. Or actually, to make sure that we're using raise correctly. Okay, let's give it a string then. It looks like it's looking for an argument, so let's say raise value error. That was it. We just needed to give it a string. This isn't like the slickest solution possible for this particular problem, right? We could have done some cool functional thing where we do like a fold or something like that. But you know what? It's readable and it's effective. It's very clear what's going on here. So that's fine. We'll close out of these. And we'll move on. Oh, I should have marked this one complete. So if we want, let's look at view community solutions for the Hamming distance one. Let's see most stars first. Yeah, see, so this would be the super slick way to do it. So zip is a really cool function in Python, which creates tuples out of two different iterables. So basically, let's not try to explain it with words. Let's do it. So for example, if let me fire up IPython because I think it's easier to read. So if we say like A equals 1, 2, 3, that's one list, and then B equals, let's do strings, right? A, B, C. If I zip A and B, let me turn it into a list because it's a zip object. Okay. You can see that it becomes a list of tuples, in which the first element is from the first list. Now, what happens if they're the different length? So if I give it D. It will only zip the ones that it has a match for. So the second the lists become unequal, then you'll have a problem. And this really doesn't work out here because I don't think this will raise a value error, right? So this doesn't actually correspond to the version that we were working with, but zip is still pretty rad. Because it will take it'll take the result of zip, and then it's doing sum of booleans, which is kind of cool. Why does that work? So what we're doing for sum is we're saying the sum of a list comprehension. God, this is too clever by half, really, but it's nice and clean. So once we take those two and combine them, we're saying, does this equal this? And we're making a list out of those results. So we'll have a list of like trues, falses, right? And because true evaluates to 1, numerically speaking, and false evaluates to 0, when you do a sum of that, so actually, watch, if I do sum of a list of true, false, I should get 3, or 2, yeah. So that is pretty clever. It doesn't handle the errors, but that's a fun solution. But again, think about how much time we just took having to understand what was going on. It's not necessarily faster than what we wrote from a performance standpoint. So as clever as that is, and I do like elegant code, it's not necessarily the best solution because it's not as understandable right out of the gate. Let's do another one. Raindrops. Oh, this is FizzBuzz. Matrix. Oof. Given a string representing a matrix of numbers, return the rows and columns of that matrix. So given a string with embedded new lines, like 987 new line, 532 new line, 667 new line, representing this matrix, your code should be able to spit out a list of the rows, reading each row left to the right, while moving top to bottom across the rows. the rows for our example matrix, 987, 532, 667. And it's columns. Okay. Are we assuming squares? This feels very much like that Rust problem I was doing the other night that drove me crazy, and then I was overthinking. So sure, let's do it. Let me exit out of IPython here. I don't need that right now. Let's download the challenge. CD matrix. Fire up Vim. Let's edit the README. Let's get another tab going. Let's do matrix test. And a third tab with the actual code. Okay. CD matrix. And we'll do... Let's look at our tests first. Okay, so matrix.row. So we're two functions, right? Oh no, even more interesting. That's cool. So we're gonna do some object-oriented programming here. We're gonna write a matrix class. Neat, neat, neat. The class will have two methods. Yep. Okay, this is gonna be fun. All right. So we're gonna say we're gonna save this in the grid variable, and we're gonna do, we'll do this as a list comprehension. Just so the basic idea is, if we're given a string, turns out I am firing up IPython again. If we are given a string like 987 new line 3 4 5, right? And let's say we'll call that we'll call that n. So let's say that's our string. If we split m at a new line, we get our rows, essentially, right? But I still need to split the individual rows at the spaces in order to get the individual integers. And one other problem, they're the wrong data type. If I look over at my test, if I look over at my test, a string is coming in, but integers got to come out. So I can, assuming that they're being kind to me here, I can do that with just an int conversion. Python will be cool that way. But I suspect there's gonna be some error checking in here. No. There doesn't appear to be any raises that I need to worry about here. So this is a little bit more forgiving, actually, than the Hamming problem in that way. All right, let's do it. Okay, so self.grid. So list comprehensions, right? That was the other part I forgot to explain. Obviously I can, do a for loop to produce the list, like start an empty list and then, append. But a list comprehension is kind of neat too. So watch this. If I do a list comprehension of my name, I can say like C4C in Taggart. Watch this. It turns into a list. That's a list comprehension. So I'm kind of like embedding the for loop inside of these brackets, and that gives me what I need. It's a really nice Python syntactical sugar. So in our case, what do we have? We have m, right? Now, with M, I need kind of a list comprehension within a list comprehension, which I can technically do, I think. So I would say R for R in, and then there's my second list comprehension. I would say let's see. So our rows are going to be R for R in M dot split by new line, right? And then I would have to say I int No, that's not going to work, because that split gives me here, but I'm not ready to convert it to an integer yet. Okay, so we know that the list comprehension works. Just say like R for R in M dot split at the new line. That gives us our rows. And the columns would be if I split this at the space, it becomes that. Oh, okay. So if I do int I, let's do this iteratively. I'm trying to be too clever with it. So let's how do I want to... I'm trying to think about how I best want to represent this. I want to represent it as a double layered list, right? Okay, so we'll start as we'll start it as an empty list, and then we'll do, okay, so for r in matrix string dot split at the new line, now we have our row. We'll say row equals empty list, and then we'll say for I in r dot split at the space, we will say row dot append int I, because I is one of those characters, right? And then we'll say at the end of that loop, we'll say self.grid.append row. That should give us our row. It's a little ugly, right? We're not doing a list comprehension or anything cool like that. But it will work. Now for row, we should just have to do return self.grid of index. Now column is a little bit trickier. For column, we can do a list comprehension, because we're going to do is return C or R index for R in self.grid. So what we're doing here is we're going into the grid, right? And for each row, we're using the column index to get the correct part of the row, and then we're going for each row. So that gives us the index, right, is the position column-wise, right? Yes. Oh, dang it. They're one based in indices, aren't they? Yes. So we're going to have to add one. Let me split my window yet again. And seriously? Okay. Let's run PyTest. Wow, that was not the result I was hoping for. Jeez. It's -1. It's -1. Right, because if they give me 1, they actually mean 0. Ugh. Now, if we wanted to be a little bit slicker with the initialization here, we could probably do something like... We do map. Okay, so that takes us to the integer, and then we're going to say map lambda. This is crazy. The problem with this is that it's going to give me a flat map, which I don't want. But we could do some nesting maps and lambdas if we wanted to be clever with it. But again, nice and clean here. Does what it says on the tin. You know, yeah, I'm using a little bit of memory here, but I would have to do that for a functional approach too. So don't worry so much about performance here. This works. It's nice and clean. There are times when you're going to want to be clever, but this isn't really one of them. So yeah, let me just check to make sure it still passes. And it does. All right, let's get out of this. And submit this one. Let's look at community solutions here. And again, we'll look at the most stars, just to see. So he's not even doing methods. He's just straight up calling it a property. Int I for our split for our split. So he was actually doing what I was trying to do originally, but just for rows, and then columns. Right? He's kind of bouncing off of self.rows and getting himself the list. And again, it's like it's a nested list comprehension up here. It's cool. Now look at the feedback here. It says, now try for the next iteration, find an O to the end solution. After that, make another iteration, try to make your code more readable. So again, you see, like, it's not always about the shortest solution. O to the end. That's a comp sci thing, but worth talking about since we're doing this. I always like to look up big O notation. Was that the Huntington Library? Anyway, big O notation is a computer science concept in terms of how complex your algorithm is. And that diagram is not illustrative in any meaningful way. This one is, though. So big O is like the order of complexity. And the idea is that the more, if as your n, the number of items you have to run the algorithm on goes up, how many steps, computational instructions do you have to perform for every of those things you have to work on? And so, like, if there's one step, right? No matter how many elements there are, if your computation takes one step, then you've got O of 1. Or like O of whatever. If it's not an iterative process, then you have a static complexity, right? Now let's say you have to perform essentially one instruction, or whatever number of instructions, a single loop, right? How many loops do you have to perform for every one of those elements? That's going to be a linear relationship then, right? So however many times, however many elements you give the algorithm, right? That's how many of those big operations you're going to have to run. That's a linear relationship, or big O of n. Now let's say you have two nested loops, which is exactly what we have. Well, now you've got a problem, because now you have it's not n times 2, it's actually n squared, right? So you have a quadratic, and look how many more computational steps that looks like. So as your n gets higher, and it doesn't take that long, your computational cost goes up really, really fast, which is why algorithm design really matters. You want to try for something like this. Now, what ways could you get to the square root of n or log of n? There are some ways. You could work through the matrix string, and because you kind of know what you can add at every point, you could just add that next thing into your matrix, and that would take you down actually to linear, wouldn't it? Because you wouldn't have to nest it. What does that look like? Yeah, sure, let's refactor this thing. I gotta go back to the matrix, don't I? Okay, so here's what we're gonna do. O to the n is fine, right? So we can have a single for loop. So instead of doing this, right, we're actually gonna do this. We're gonna clear all this out. For C in matrix string. What are the possible situations? The first thing is, if C is a new line, then let's actually, you know what? Let's start it out with an intro nested. You'll see why in a second. Let's start it out as two lists, as a nested empty list. Okay, if C is equal to a new line, then we're going to, what we're going to do in that situation? We're going to self.grid.append a new empty list. Okay? If C, let's do elif. Elif C is equal to a space. Actually, we don't have to do anything, right? If C is equal to a space. So, well, let's put it in there anyway. So if C is equal to a space, we're just going to hit continue. And that's an elif, because we need them to be exclusive. Okay? The only other possibility in our string is that it's a number, right? So then we'll say self.grid -1 because we can get to the last row, right? Dot append int c. 1 loop rather than 2. And we should, I could be completely off my rocker, but I'm pretty sure this will give us the same result. No. Oh. What did I forget? Double-digit values. Right? So what we'll want to do... Let's see. We need a buffer. We need a buffer to keep track of our strings, our numbers before we get to the end here. So, we're actually going to say, yeah, numbuff plus equal, numbuff plus equals the character. Yeah. So it's not, if it's a space, we don't just continue, we do a thing. We say self.grid, here we go, -1, this is where we append the number. Dot append the integer value of the num buffer. Yeah. And then we reset the num buffer. Now, this looks like we're doing more computation, but we're not, because again, we're still in 1 loop rather than 2. So we're saving ourselves computational time. Sorry, I forgot to write, I think. Everything looks good. I'm not getting any syntax errors. Oh, come on. I forgot to... Oh, I think the logic is reversed. So basically, I have to clear the num buffer in almost every case, except if it's another character. So okay, we'll do it. So in both cases, if it's a new line or if it's a space, we have to set up we have to clear the buffer and add it to our... Seriously? What am I getting wrong here? So interesting. Oh, I'm not clearing the buffer at the end, right? Let's do the same thing. Now this is bad programming so far because I'm repeating myself a bunch, but clear the buffer at the end. Yeah, see, that was it. Okay, so our logic is working. Now how can we clean this up a little bit? Int. All right, let's try. Actually, okay. So now we've taken out the need for the elif here because we are accounting for both spaces and new lines. All we need to do is account for the new list, the new row. Okay, still passing. And then we have this like last piece here where we're doing the append at the end here. I don't love that we're repeating that, but for an iterative process, it's still okay. If I wanted, I could, you know, write a clearer procedure. Now, it seems like there are a lot of instructions here, but the truth is that, again, you have to, the individual instructions matter less than the stuff that has to repeat, the number of steps that have to repeat every time for every element of the iterable. So, big picture, like, we kind of take the individual steps out. we stop considering this number because this number is going to remain small, but the number of loops that we would have to do will get huge as we consider, you know, if we go back to the big O notation chart, as the number of, like, the length of the matrix string in this particular case, as that got gigantic, right, the number of loops is really what we're concerned with. And so now we've gone from a quadratic complexity, right, 2 loops and nested, which would be O of n squared, to just a single loop every time. So that's O of n. So actually a more computationally efficient algorithm. All right. Well, I think that's going to do it for tonight. I hope you had fun playing with Exercism. I hope you get some good practice out of it. I really like this platform. I like kind of working through it and seeing other people's solutions, as well as the suggestions for improvement. As you can see already, you know, 2 lessons in, we were making progress. So yeah, that's going to do it for tonight. Thanks everybody for hanging out, and we'll see you on Saturday with some more hacking. Take care.